Okay, you're given this line right here, 2x plus 5y equals minus 5 equals 0, and you want to find the point on that line that's closest to this point. I'll quickly go through the idea that you can actually find the coordinates of that point without using any calculus at all. Here's the original line, written as f of x equals negative 2x plus 1. And if you could find the equation of this red line, which passes through -4, -1, and is perpendicular to the original green line, then find the point of intersection of those two lines, you'd have the point that's closest to the point -4, -1, because the distance between 2 points is shortest when it's on the perpendicular. Okay, so here's the equation of the perpendicular. The slope is the negative reciprocal of -2/5. And I used point slope, but rewrote it this way. Set those two parts equal to each other using the substitution method. Multiplied every term by 25 and simplified. And there's the answer right there. That gives you the x-coordinate of this point right here. And if you substitute that back into the definition of the function, -2/5 times -80/29 plus 1, you get a y value of 61/29. Now, how do you do that with calculus? Well, I'll go back here to board 1. Realize that for any point on this line, if the abscissa or x-coordinate is x, then the y-coordinate will be indeed -2/5 x plus 1. So if we could find a formula for this distance and then take the derivative and set it equal to 0, we'd have probably the x-coordinate that would give us the shortest distance. So using the distance formula, it's the change in x, which is x plus 4, the quantity squared, plus this thing minus a -1 would give us the -2/5 x plus 2, the quantity squared. Take the square root of that, and you've got the derivative. And here's what that looks like. There's a formula for the distance between the point -4, -1, and any other point on that line. And if you take the derivative, you could think of this square root as being written to the 1/2 power. Apply the power rule, 1/2 of whatever's under the radical, reduce the exponent by 1, and then here's the key, multiply by the derivative of the inside. So the derivative of this term, power rule again, 2 times the quantity x plus 4. For the second term, power rule again, reducing the exponent by 1, but now you have to multiply by the derivative of the inside, which is -2/5. And if you rewrite this with this radical in the denominator, you can actually visualize these 2's canceling out. And if you set it equal to 0, you'll multiply both sides of the equation by the square root radical, and you'll just get this part equals 0. And so that's what I've done here. X plus 4 plus distributing this -2/5 plus 4/25 x minus 4/5. When does that equal 0? Multiply through by 25. This looks eerily familiar. Exactly what we got on board 1 when we weren't using calculus. Okay, and so there is technically you would have to prove that this x value generates the minimum distance, but we'll accept that as true for right now. And if you plug that back in, I think we got 61/29. These are the coordinates of the point on the line that is closest to the point -4, -1. There you go. Hope that helped. If you have any questions, post a comment.